Hello guys, welcome once more to another video again in my channel. So in today's video, as displayed to you, we will be looking at the Cameroon GCE Advanced Level Physics Data Analysis GCE June 2019 of question 7. Okay, so guys, as displayed to you, data analysis is an important question in the A-level physics paper 2, and it is very complicated to some students, okay, in managing their time. And in fact, it is complicated when it comes to accuracy, time management, okay, and time management. All right, so this video is going to direct you in the steps for you to take, okay, so that you actually plot a graph and do your calculation within 30 minutes. All right, so without wasting much of your time, let's dive into it. All right, so guys, that is the question displayed to you. And before we begin, please, this video is very important. Things on these videos on data analysis, please, I recommend that you should follow them up. Please, they are very important. So if you are new in my channel, please watch my previous videos, and if you find this other video helpful, please don't forget to subscribe, like the video, and share. All right, so let's read the question together and then we start the solution. Okay, all right, so a student investigated the variation of potential difference V and the current I through a semiconductor diode and obtained the following results. So these are the current values. These are the voltage values or the PD values. But what do you notice? This voltage is in millivolts. So I decided to in each other video, I converted my volts, my millivolts to volt. But in the last video, I did not convert my microamperes to amperes. So actually, you are going to look at the differences when plotting graphs under data analysis. The importance of you converting the quantity to the required quantity. That is like this millivolt, right? Millivolt is not actually the unit of volt. The unit of voltage is just volt. All right. So let's continue. So these are our current values and these are our voltage values. All right, so the equation relating I and V is I equal to I naught e power beta V, okay, and the label it equation 1. So where I naught and beta are constants, so the A part says plot a suitable graph from which I naught and beta could be obtained, and they gave this for 11 marks. The B part says determine the values for the constant I naught and beta, and this came for 8 marks. C says what is the physical significance of I naught. So guys, that is a question displayed to you. So you can reach me on WhatsApp via the telephone number displayed to you on your screen so that you can be added. If you are interested, you can be in our general WhatsApp forum where past mock questions, GCE questions, and so on PDF notes are being shared there. All right. So actually, if you want to be added in the general WhatsApp forum, right, you can contact me on WhatsApp so that you can be added, both O level and advanced level. So let's begin. All right, so let's look at the solution. So this is our equation given to us, right? I equals I naught e power beta V. Okay, so from here, it is a choice for you to use either log or ln. So it is your choice. You can use either the log or the ln. All right, so according to logarithms. So me, I decide to use ln. So if I take ln on both sides, I have ln I equals to ln I naught e power beta V. Okay, all right, so from here, we have to note that ln A times B is just ln A plus ln B. Okay, according to logarithms. Okay, so from here, right, I can just write it and then I expand it. Okay, so this is the same thing here. I just included the multiplication sign, but it's still the same thing. So I have ln I equals to ln I naught times e power beta V. Okay, so from here, if I apply now this law, I will have that ln I equals to ln I naught plus ln e power beta V. Okay, but from here, this is another important property again when it comes to logarithms. Okay, so from here, ln e power beta V, I can just take this power beta V, then I bring it down. Okay, so that at the end of the day, I will have ln I equals to ln I naught plus beta v ln E. Okay, I've just applied a law in logarithms. Okay, all right. So from here, right, we know that ln E is just equal to 1. So just take a scientific calculator and then you input ln E. Your answer will be 1. Okay. So since we know that ln E equal to 1, therefore at the end of the day, we will have ln I equals to ln I naught plus beta V, since all this is equal to 1. Okay. So that is it. From here now, we can just rearrange the equation. So if we rearrange the equation, we'll have ln I equals to beta V plus ln I naught. Okay, so now you can clearly see that we are plotting a graph of ln I naught against voltage with slope beta and intercept ln I naught. Okay, so that is it. We are plotting a graph of ln I with ln I against voltage with gradient beta and intercept ln I naught. All right, so clearly you have two cases or two choices. It depends on you. So for the choice one, we have, you can write this equation like this, and then you conclude that this equation is just like the equation of a straight line like this. So just write it like this and you will not be penalized. Okay, so it means that this is an equation of a straight line. Okay, so if this is an equation of a straight line, it definitely means that this equation 2 is actually the equation of a straight line. Therefore all linearized equations are straight line. Okay, it means if you plot your graph will be a straight line graph. So take note when you be plotting your points and it's coming out like a curve. So please, you can just cross-check your work. Okay, cross-check your work and ensure that there are no errors. All right, so either you use this format or this other format. So after linearizing, you can say that you are plotting a graph of ln I against voltage or against V with gradient beta and intercept ln I naught. So either this or this is actually accepted. Okay, so but don't continue without you telling the examiner, either telling the examiner about this or this other part. Okay, so that is it. So guys, let's continue. I hope it is clear. All right. All right, so this is our linearized equation, right? So from here we can obtain our process values. So this is my I values. These are my voltage values, and these are my process ln I values, and these are my voltage values, not millivolt. This is voltage in volt, and this is voltage in millivolt. Okay guys, so here please be very careful, take notes, and please, I recommend that you should follow up. All right, so I'm working out with my ln value. Since I'm not plotting a graph of I, but I'm plotting a graph of ln I, means I'm to obtain ln I. So how am I going to obtain ln I? It means that you come to the I values, right? Like this one. So you take 0.04, 0.004, then you multiply it with this value. And then your answer, you take the ln of that answer. That is, you pick up your scientific calculator and then you take 0.004 times 10 power minus 4. That will give me 4 times 10 to the minus 7, and then you take the ln of that answer. So you have negative 7.3, negative 14.73. Okay, so this is it in two decimal places, and then you do the same here. You take 0.016 times 10 to the minus 4, and then you take the ln of that answer. You have negative 13.35. So you do the same right up to this last value here. Okay, all right, now because this part actually most students actually forget about this thing written up here. Okay, because I remember there's a question there, maybe just June 2023, or that they gave something pressure and then they give it in kilopascal, and then some students actually they miss out that times 10 to the power 5. They just take this value and they took the ln just like that, and we go into the ln. So that is actually wrong. Don't forget this value up here. This value up here is very important. This value up here simply means that you take this. It means that these values, right, were maybe they were much. Okay, so they condensed it to this other power here. So it means that if you want to look for the ln of this value, you have to multiply it first with this other power here, then before taking the ln. Okay, so that is it. So now for the millivolt, right, we have to convert from millivolt to volt. So this is our millivolt. We have to convert to volt. Okay, actually these are our raw data. So these are our processed data. Okay, so we are going to use this processed data to plot our graph. Okay, all right, so how are we going to convert from millivolts to volt? So yeah, milli means divide by 1000, or you multiply this value times 1 over 1000, or you multiply this value times 10 to the minus 3. Okay, so if I take my calculator and then I input 255 times 10 to the minus 3, I will have 0.255. So here was supposed to be 0.255, but to two decimal places is just 0.26. Okay, so you do the same here. You take this value, either you divide it by 1000 or you multiply it times 10 to the minus 3. So this will be your answer to two decimal places. And when you are doing this, please don't forget to round up. If it depends on your decimal places. Some people might take 3 decimal places, but me, I decided to take 2 decimal places. All right, so that is it. And you continue right up to this last value here. Okay, so if it means you take 515 times 10 power minus 3, which will give you this value. Okay, so that is it. So now we are plotting a graph of lean of all this against voltage, but not millivolt. Okay, so we are plotting a graph of this against voltage, but not voltage in millivolt. It is voltage in volts. All right, so the graph is going to be displayed to you. Please again stay tuned here, because here these are the relevant parts of the data analysis. This is the first part I explained here, and then we are going to look at the second part. Okay, all right, so this is my graph, right? I've plotted the graph already, so you're just going to be following me up as I'll be doing it. All right, so it means, so these are my voltage values. You notice that this graph is, look at how the axes are being labeled. So we have from negative 8 right up to 18, and then we have from, since our values of the voltage, right, our voltage values. Okay, this is our vertical axis. It means we come here for the lean I axis, for the lean axis. Okay, it means we know that it ranges from negative 14.73 right up to negative 8.41. Notice here that negative 8.41 is bigger than negative 14.73. Okay, so now you notice again that from here, right, if I decide to round up this 6, I'll have 0.3, and you notice again that here will also be 0.3, and here will be 0.4. If you round up the values, here will be also 0.4. Okay, so these values, right, I decided to leave it in two decimal places for the purpose is that if I round up all the values for me to plot in one decimal places, you notice that the values will be repeating. So here I will have 0.3, 0.3, 0.4, 0.4. So what I'm going to do is that I'm going to multiply this term here times 10 to the minus 2, such that I'll be plotting my graph directly to two significant figures. Okay, so you notice that from here, right, from here, if you take this axis times 10 to the minus 2, it means you have 26 times 10 to the minus 2. So take 26 times 10 to the minus 2, you will still have this value 0.26. So I have 26 times 10 to the minus 2, I have 0.26. So it means here, for you to avoid the continuation of values, right, like values keep on repeating. Okay, so you just take that value, this axis here, you multiply it times 10 to the minus 2. The examiner will know that you including these two significant figures at times 10 to that minus 2, it means you are actually plotting these same values here. Okay, so that is another point again. All right, so let's come back here. As I earlier said, negative 8.41 is bigger than negative 14.73. 0.73. So here I'm going to plot my values to one decimal places, okay, because we have 14 point, so it means I'll have negative 14.7, negative 13.4, negative 12.5, negative 11.6, negative 10.9, negative 9.8, negative 9.3, negative 8.9, and we are negative 8.6, and finally negative 8.4. Okay, so I hope you know how to round up values. All right, so if you have had your scale, so how are you going to derive the scale now from here? I notice that if I decide to draw my, let me say, let me just demonstrate something here. So let me say this is my axis, right? These are my quadrants. So why is these values coming out like this? Because it's simply telling you that this x direction is positive, and the y direction is negative. That is why these other portions are being cut off. So we are not interested in the positive y direction. So this is the positive y direction, this is a negative y direction, and this is a negative x direction, while this is a positive x direction. And you notice that these values here are positive. Okay, they are all positive. It means we are working from this side going this other direction. Okay, and then you notice again that these other values here are negative. So it means that we are moving from the origin right up to the negative values, which are the last negative value there is the last negative value is, according to the line axis, it is negative 14.7. Okay, all right, so that is a better explanation. Please take note. So when your values are coming out negative, just take your time and draw this quadrants. So this is the first quadrant, second quadrant, third quadrant, and the fourth quadrant. And you notice that we are actually working in the fourth quadrant. Since the x direction is positive while the y direction is negative, it means we are in the fourth quadrant. If the y direction is positive and the x direction is also positive, it means we will be in the first quadrant. If the x direction is negative, like all these values here are negative, right, while these other ones here are also negative, it means we'll be in this third quadrant. All right, please take note. Okay, so let's continue. Okay, so from here, right, if you have, okay, now let's derive the scale. How are we going to derive the scale? All right, because this is another complicated part. Okay, all right, so this is my, let's begin with the vertical axis. So this is my vertical axis, right? So what I did is you can actually just figure it out there. So because you can clearly see that these values are actually increasing by, let me see, the vertical axis, right? You can see that it is actually increasing by 2. Okay, so we have 8, 10, 12, 14, 16, 18. So it means that the difference is actually 2. Okay, all right, and then so from here, this is it. So we are here. You can actually just conclude that we have you can just have 2, 4, 6, 8, 10, 12. No, sorry, 8, 8, 10, 12, 14, 16, 18. So it is clear from here. Okay. But anyways, if you cannot figure that out directly, just take this value. It means we take this negative 14.7, right? Note I'm plotting using one decimal place, not two decimal place. So it's negative 14.7. Okay, then you increase the value to, let me say, 16, negative 16.0. Okay, so if you increase the value to, let me say, negative 16.0, and then come to this other direction too, this is negative 8.41. It means you can shift it to negative 8.0. Okay, then you take the difference. Okay, so you have negative, note that this is bigger than this other last value, so it means you have negative 8.0 minus minus negative or minus negative negative 16.0, because you have shifted this value a bit. So if you shift it, the reason of you shifting it is because you want that the value should enter to your graph paper. Okay, so that is the reason of you shifting the values a bit. So if I shift this negative 14.7 a bit, I'll have to, let me say, shift it to negative 16.0, and then I'll shift this other one to let me say negative 8.0. It means I'll take negative 8.0, which is the highest value, minus negative 16.0, which is the lowest value. So the answer now, I'll actually divide the answer divided by the number of lines that I'm about to plot. Okay, so let me say these lines here, right, they are, let me say, because normally in a graph paper, right, they are actually 22 or 21 of these lines. Okay, so it means that if I take that value, negative 8.0, or actually just ignore the negative, work with the positive values. So just take 8.0. No, if you ignore the negative values, right, it means you will be taking 16.0 minus 8.0. Okay, so the answer that you have, let me say 16 minus 8. So it means I'll have 8 then divided by my number of divisions. So it means I have 1, 2, 3, 4, 5, 6. So I have 6. So divided by 6. So I have 1.3. Okay, I have 1.3. So it means that you can conveniently see that um the scale is actually increasing by 2. So it is 1.3. So you can just round it, up to 2, 2.0, so that your scale can actually be increasing by 2. Okay, so it is clear. So what you do is that for you to derive your scale, take the highest value, shift it a bit. Let me say if the highest value is 20, shift it to, let me say, 22, and then take a least value, let me say it is 5, shift it to 4, and then take 22 minus that value, which is 4, and then divide it, the answer, you divide the answer divided by the number of divisions that you are about to plot. On the original graph paper, right, you divide it divided by 22 or 21, so that if your answer, and choose a precise number like 2, your scale should be increasing by 2, 1.5, 0.5, 10, 5. Okay, but not 3. You can actually be increasing by 3, but 3 is actually somehow odd. All right, so that is how you derive your scale on both axes. So for the vertical axis, that is how you do it. Now next, how are we going to know each of these small lines, so that like how this point is actually plotted here. How are you going to know that this point is plotted, this point here is plotted on this particular place? Okay, so let's continue with that. So what you do is you take the this is your starting point, right, on the vertical axis, and this is my starting point on the horizontal axis. So let me just use this one, which is positive. So it means that you go to your starting point, you shift next. So the second point. Okay, you take the closest point to your starting point, you minus the starting point from that closest point. It means you take 25 minus 20. Okay, then let me say 25 minus 20 is actually 5. Then you take 5 divided by the number of division between that two values. Okay, so 25 minus 5, 25 minus 20 is 5. And between 25 and 20, how many divisions are there? So we have 1, 2, 3, 4, 5. So we have 5 divisions, or 5 boxes. 1, 2, 3, 4, 5. So it means that you take now the 5 divided by that number of divisions, so that will give you 1. So it means that this one small line or one small box is actually 1. Okay, let's move to the vertical axis. So it means that I'll take, this is my starting point, I'll take this value, then minus this value. So I'll take, you can just ignore the negative for that. So just take 10 minus 8. That will give you 2. And then you take the 2 now divided by how many divisions are there between this negative 8 and this 10. So it is actually, there are 5 divisions. Okay, so you take divided by 5. So it means I'll have 0.4. It means one of my small line here is just 0.4. Okay, so I hope it is clear. So it means one of my small line is 0.4. Please note it down. For the vertical axis, one of the vertical axis is increasing by 2, and one of my small line is 0.4. Please note it down. And then let's move now to the horizontal axis. My horizontal axis is increasing by 1 because I have 20, 21, 22, 23, 24, 25. So it means it is increasing by 1. Okay. So, and one of my small lines there is I don't know what was one of my small lines here was, let me say, okay, it was 1. Yes, it was 1. Because I'll take this minus this is 5. 5 divided by 5 is 1. But yeah, this minus this is 2. 2 divided by 5 is 0.4. So it means my small line is 0.4, while my small line is 1. Okay, so take note of that. All right, so now if you have your graph paper, right, first thing you do, you actually rule your line. So you see that this value is pointing downward. Okay, it's pointing downward because the scale is actually increasing in this order. All right, so if you rule this line and then you rule this other line here, okay, if you rule this line, right, you label it line I. Okay, I did not include this other part for it so that the just to economize space. Okay, so I have the line I, you label it line I. Always label your axis, please. You label it line I, and then you rule the other horizontal axis and you label it V in voltage. Note, I decide to include this times 10 to the minus 2 because I'm plotting using two significant figures. Okay, so 20 is still the same as this 20 times 10 to the minus 2 is the same as 0.20. So that is it. So here I've just derived my scale. That is why my values do not actually begin from 26. But it's a choice. You can actually make your own values to begin from 26. Okay. So that is it. All right. So these are my axes. I've labeled them because I'm plotting. You can see that my voltage values are in decimal places, but here they are not in decimal places because of this times 10 to the minus 2. So if I take times 10 to the, if I take, let me see which value there. If I take 0.32, right, times, and sorry, if I take 32 times 10 to the minus 2, I'll have 0.32. So it's the same thing. All right, this is just in the index form, so that I've just condensed the whole of these values to normal significance figures, to two significant figures. Okay, so, or to whole numbers. These are actually whole numbers. All right, so what next? We have labeled our axis, right? So the next part we do is that, let's come here. So it means that we have, our first point is negative 14.7, and then when the vertical axis is negative 14.7, our horizontal axis is 0.26, or sorry, it is 26, not 0.26. Okay, because we have, you see, we have just included times 10 to the minus 2. All right, but you can equally include it here. You can equally include it, but just that just to economize space. Okay, yeah, you can actually include it. You can draw another column here, and then you put v times 10 to the minus 2. All right, so here we are, when the vertical axis is negative 14.7, my horizontal axis is 26. So how are we going to do that? So we move, since we know that one of our small lines is negative, is 0.4, it means this is my 14. But how am I going to get 14.7? It means that I will come here. This is my 14. This is my negative 14, right? 0.7, it means you are going downward. All right, so it means I'm gonna have, this is 0.4. It means from here to here, let me take 0.4 plus 0.4. So it means you take 0.4 plus 0.4. You notice that it is 0.8. So this is 0.4 plus 0.4. So it means here is 0.8. So you can conveniently plot the point here or in between this box, but it is good for you to plot it here. Okay, you can shift either 0.8 or 0.7. It is still correct. Okay, so that is how you plot that point there. Okay, let's move to the next point, which is negative 13. All right, okay, so we have, this is our negative 14.7. So this is our 0.7 here. Now let's move to the horizontal axis, which is 26. So it means you extrapolate from here. This is our 25. So since this k is increasing by 1, it means here is 26, 27, 28, 29, 30. So it means here is 26. So it means we will have negative 14.7, 26. So it means you plot the point here. Okay, so that is it. All right, and then to our next point, we have negative 13.4. So we have rounded up this 5, we are plotting in one decimal place. We have negative 13.4. So it means you come here, this is our negative 12, but where is negative 13? So let's see. So this is negative 12, so 13 must be somewhere here. So let's see. So we have negative um sorry, this is okay, negative 13.4. So let's see. But this our scale, this one of our small box is 0.4. So let's see. So I'll take 0.4 plus 0.4, means this plus this. I'll have um I'll have, let me say, 0.8. 0.8 now. So I will take now that's 0.8 plus the previous value, which is negative 12. So plus 12, just the negative for now, plus 12. So we have 12.8. You can see that we are actually dealing with 13.4. So it means plus 0.4 again for it to shift. So we have 13.2 now. We have 13.2, of which if we add 0.4 again, the value will be more than. So it means here we have our 13, which is somewhere here. Yeah, which is somewhere here. Okay. So it means we have from 1, 2, 3. It means take 0.4 again times 3, which is 1.2, then plus the previous value, which is 12. So we have 13.2. It means here is 13.2. It is clear that here is 13.2, but we have to plot negative 13.4. So it means that this 13.2, right, if we decide to add plus 0.4 again, it means the adding plus 0.4 means you are shifting again to the next small line. So that will be negative 13.6, which is more than. So that is why it means if you plot the point here, right, it will be 13.6, which is more than. So that is why we decide to break here, which is 13.2. Okay, so that is it. So for the horizontal axis, it is actually 32. So you can move down. This is 30, 31, 32. That is why the point is actually plotted here. So that is done for all the values. So I'm doing this in order to reduce the cost of megabyte, because I can actually explain to all the values. Okay, so that is it. All right. So next, if you are done plotting your points, you can actually draw now a line of best fit. So if I draw my line, right, so I'll have this. Okay, so that is my line of best fit. So from this line now, please, again, your line of best fit should be thin enough. So it means you have to use a sharp pencil to draw it, and a transparent ruler, as I emphasized in the last video. Use a transparent ruler to draw a line of best fit. All right. So next, your line of best fit, you're not supposed to print it 2 times. You just put your ruler and then you draw it once. Okay. So now, right, means from here we are going to calculate our slope. So if I draw my slope, please, your triangle should be big enough. And again, your slope should not, don't draw your triangle to any of the plotted points. Don't use the plotted points. Okay. It means your triangle can begin from here, or from here, or from here, depends on you, but don't make a triangle what am I even trying to say? It means don't use the plotted points to link your triangle using the plotted points. No, it is wrong. So what you are going to do is just look at how I'm doing it. So you see that my triangle it begins from here, and then it also begins from here again. See, so these are my plotted points. So I did not include the triangle to any of the plotted points. Okay, so if you draw a triangle, right, for you to calculate a slope. Okay, then what next? If your triangle is ready, so it means you can just actually extrapolate. So it means, why are you extrapolating? It means you'll be reading this value on the vertical axis and on the horizontal axis. Okay, so this is my vertical axis. When I'm reading like this, I'm reading it horizontally, which is on my vertical axis. Yeah, vertically, which is on my horizontal axis. Okay, so that is it. Equally, I'll also extrapolate this other part again. Extrapolate it like this for easy for you to ease the reading of that value. Okay, so that is it. And then extrapolate it again horizontally. You have it, means you are reading this value like this horizontally, which is means you are actually reading the vertical scale value. All right, so from here, let's read out the values. We know that our horizontal axis is increasing by 1, and it means that one of our small line is 1. Okay, so it means that from here I have 45, and you note when you are reading the values, include the x value first before the y values. All right, so it means from here I have 45, 46, 47, 48, 49, 50. Means here is 49. Here is 49. Don't forget to put times 10 to the minus 2, please. I hope it is clear. Don't forget to include the times 10 to the minus 2. Alright, so it means here I will have that. Okay, let's read the corresponding vertical direction. So it means from here, right? So I have, when I'm reading, right, you begin from here. Don't begin from negative 10 and going upward. No. Start from negative 8 because the scale is increasing like this. Alright, it means here we know that one of our small line is 0.4. It means we take, how many of them are there? So it means we have 1, 2, and 3. So it means that I take a calculator, you input 0.4 times 3 of them, because the line force when actually this was just when I was extrapolating. This line actually falls on this small line down here. Okay, so it means this is number 1, 2, 3, and 4. So it means this line falls on the number 3 line. Okay, so that is why you take 0.4 times 3, which is 1.2, and then you add it to this value. Okay, which means you plus negative 8, plus negative 8, plus negative 8. Let me say 1.2. Let me say just add the plus 8, then it is actually 9.2. But since you are going the negative direction, or since the values are negative, it means just include negative 9.2. It means here is negative 9.2. But how are you going to write the values now? It means you put 49 times 10 to the minus 2, comma, negative 9.2. So include the x-axis first before the y-axis, the y value. All right, so if that is done, it means that here I'm going to have, so let's read these other values here. So you notice that here is just from 20 to 25. So you notice that this is 21, 22, 23. So I can actually choose 24 because this line is closer to 24. So it means I'll have 24 times 10 to the minus 2, which is here according to the axis, comma, let's read these other values here. So it means we are moving from negative 14 going downward. So but we know that one of our small line is 0.4. And how many of them are there? 1, 2, 3. So I'm on the third one. So I will take 0.4 times 3. The answer, and then I'll add it to this negative 14. So I will have negative 15.2. So that's why I have 24 times 10 to the minus 2, comma, negative 15.2. Okay. Then similarly, I will do the same here. 49 times 10 to the minus 2, comma, negative 9.2. So that is it. I hope it is clear. So that is it. That is how you do your graph. I hope it is clear. Please, if you are not understanding, you can actually reach me on WhatsApp or in the comment section. All right, so let's continue. Any other thing again? Please, okay, let me just explain some things here. So how are you going to calculate your slope? So don't forget that our slope, right, which is from this, our slope is actually beta. Okay, so how are you going to calculate it? Or let's say how are we going to calculate because the question said we should calculate beta and I naught. Okay, or how are we going to do it? So it means this is our beta, right? So for us to calculate our beta, it simply means that just calculate the slope, then equate it to our beta. But how are we going to calculate ln I naught? Since our graph doesn't begin from 0, it means we have to use the point. So I can either choose this point, this 49 times 10 to the minus 2, comma, negative 9.2, to calculate this ln I naught. How? It means I will go to this ln I. What is my ln I actually? My ln I means that it is this value, this negative 9.2. This is my value. If I choose these 2 points, right, for me to calculate this ln I naught, okay, it means if I decide to choose this 2 point, it means I will take this negative 9.2 and put it to where I find my ln I, and then my slope, which is my beta, will be the slope I've calculated, okay, or the slope I'll calculate. And then what will be my v? My v is simply the horizontal axis, a point on the horizontal axis, which is 49 times 10 to the minus 2. Notice that I took the point which were actually together. Don't come and take this point here and you come and take this other point here. No, it is wrong. So if I take this my v now, which is 49 times 10 to the minus 2, I substitute it here, and then I substitute my beta. equally calculate my I naught, my ln I naught. Okay, I hope it is clear. All right, so what next? Let's go and calculate our slope now. So the B part says determine the values for the constant I naught and beta. So and that question they gave 8 marks. So how are we going to do that? We know that for us to calculate this our constant, right, we have to calculate our slope. So how am I going to calculate the slope? So I know that my slope is just change in I over change in V. But some students use y2 minus y1 divided by x2 minus x1, which is actually wrong. That is only true for mathematics. But here you have been given that your y is ln I naught, ln I, and your x is v. So it means that you have to take the change now is ln I naught 2 minus ln I naught 1 divided by v2 minus v1. So if I use that my point, the point I took on my line of best fit, it means my slope will just be negative 9.2 minus minus 15.2. Why? Because my highest value was negative 9.2 on the graph. You can backward it for you to see, and you can backward the video for you to see. And my highest value was negative 9.2, while my least value was negative 15.2, according to the triangle I drew. Okay, so it means I'll take my highest value minus my lowest value. So that's why I have negative 9.2 minus minus 15.2. And then equally for the my horizontal axis, which is my voltage axis, I'll have 49, which was my highest value, minus 24, which was my least value, and then times 10 to the minus 2. Okay, so that is it. So if this is done, I'll have my slope equal to 24.0 per volt. 24.0 per volt. Why? Because when you take the ln of a quantity, right, the unit disappears. So it means here I will be left with volt. So it is like saying 1 over volt. Okay, like saying 24.01 over volt, which is just per volt. All right, so that is my slope. But my slope is just equal to my beta. Okay, my slope is my beta, as I earlier explained in the previous slide. Okay, so if my slope equal to my beta, it simply implies that beta is just equal to 24.0 per volt. Okay, so that is it. And then so now we have to calculate I naught. Okay, so how are we going to calculate I naught? As I earlier explained, we are going to use the point 24 times 10 to the minus 2, comma, negative 15.2 from the graph to calculate I naught. Okay, so I decided to highlight this in red, and these other values, this in green and this in blue. For some reason you are going to see. All right, so um from this equation, right, ln I equals to bv or beta v plus ln I naught. Okay, so my ln I, as I earlier explained, is negative 15.2, which is this value here. And then my beta is my slope, which is 24.0. And equally, my voltage axis, my voltage point that I took with this other point here, as displayed here, it is 24 times 10 to the minus 2. Okay, so now knowing these values, I can just substitute them in this equation for me to calculate in I naught. Okay, so at the end of the day, if I substitute these values, you notice that my ln I naught is negative 15.2 equals to 24.0 times, you notice that this is my beta. According to the equation, we have beta times v, beta times v, of which I know that my v is 24 times 10 to the minus 2, and then plus ln I naught. So if I take this times this, I'll have my answer, and then I just send the answer this other side so I can calculate my ln I naught. So at the end of the day, my ln I naught is just equals to 5.76 being equal to negative 15.2. It means if I take this times this, I'll have 5.76. Okay, and then for me to calculate, this is just a simple linear equation. So for me to calculate ln I naught, I will just take this term here and then I cross it. Okay, and here it is positive. If it crosses its equality sign, it becomes negative. Hence, I will have ln I naught equals negative 15.2 minus 5.76. So if you take a calculator and then you input negative 15, negative 15.2 minus 5.76, you have negative 20.96. So that is my ln I naught, but the question says calculate I naught, the constant I naught, not ln I naught. So how are we going to calculate our I naught? It means that we just take E on both sides. So how are we going to take E on both sides? It means that you take E on both sides like this. Take E power ln I naught equal to E power this value here, which is negative 20.96. But you have to note that since E power ln x is equal to x, it means that E power ln I naught is just equal to I naught. Hence, our ln I naught is just equals to E power all this value. And if you input all this value to your calculator, you have I naught equal to 7.89 times 10 to the minus 10 amperes. You know, I naught is actually current and it is measured in amperes. All right, so that is it. So there's an important note here that some students don't know how to input this E power negative 20.96. So this is for you. You have to know that E power negative 20.96, it means you go to your calculator, you go to alpha, you press alpha, and then you press E power n, where n is this value here, this negative 20.96, and then you press equal to on your calculator. So just follow this simple procedure here and you do it, you have this answer. And you do it for many of data analysis questions because they always come in this form, ln, and log. Okay, so that is it. And then equally for log, right? If here was log, not ln, it means we know that log is in base 10. So it means that you just take if here was log I naught, right, means we just take 10 to this other side, 10 to the power this value to this other side. I hope it is clear. So guys, this is the end of this video. Please, if you find this video helpful, don't forget to subscribe to the channel, like the video, and share to your friends. So guys, stay tuned for more data analysis videos and other advanced level videos in mathematics, physics, chemistry, even biology, and further mathematics. All right, see you in the next video.